Good morning, grade 9. Today we're going to talk about multiplying powers. So let's say if I have a as a variable exponent 4 times a exponent 3. For sure, if I am a student from grade 8, which means I didn't get any information about let's say the exponent law, in this case, the way that I'm going to solve this problem, it's going to be like that I'm going to break down the A4 to A times A times A times A, time the A exponent 3, I'm going to break it down to A times A times A. And at the end, I'm going to say that this equal to 1, 2, 3, 4, 5, 6, 7. That means A exponent 7. This is the way that we are using for grade 8. However, for grade 9, now we need to know about the first exponent law. It's related to the multiplication power. In the multiplication power, we are saying if I have a base A exponent m times the base A exponent n, since I am multiplying with the same base, and this is a very important condition that it has to be with the same base. If I'm multiplying something like that, the answer is going to be the same base A, m plus n. That means we add the exponent. So in my case, it's going to be A, because A is the same base for both of them, exponent 4 plus 3. Since it's multiplication, I add the exponent, which means A exponent 7. So you can see here that I used the first law for the exponent to add the exponent instead of breaking down as grade 8, as you can see here. So let's see more example to understand it better. If it's I have a question saying simplify each of the following, and I have something like that. 3 to the power of 7 times 3 to the power of 2. I see here that I have the same base 3. That means I can add the exponent. That means it's going to give me 3 exponent 9. Again, for this example, I see that I have the same base for the 3 terms here. That means I can use negative 2, and since it's multiplication, all I have to do is to add the exponent 5 plus 2 plus 3, which means I have a base of negative 2, exponent to what? 2 and 3, 5, 5 and 5, 10. That means negative 2 exponent 10. What about the next one? The next one, I still have the same base, and this is my condition. That's why I'm going to use 4. Now, regarding the multiplication, I add the exponent. That means 5 plus. This is negative 2. So, for sure, I need my information from the integers, and I have to say, in this case, 4, it's my base. 5 plus negative 2, that means 5 minus 2. That means 4 exponent 3. And the last one, I see a multiplication, but there is something very important. I see different base. 2 is different than 3, 2 is different than 3, so I have to be careful. In this case, I have to make sure that I combine only, or I use the exponent law only between the same base. So here, for the base of 2, I have 2 exponent 3 and 5. That means 3 plus 5. This is what it's related to the base 2. And after that, times, regarding the base of 3, I have 4 and 1. That means 4 plus 1. That means 2 exponent 8 times 3 exponent 5. And in the question, it's saying simplify. It didn't say evaluate. If it's saying evaluate, I have to continue and find the value of each. But here it's saying simplify. So this is how I can simplify. And for something like that, if I have a question saying determine the value of the missing exponent in each of the following. So let's see this one. This one, I have 3 exponent 4, or to the power of 4, times 3 to the power of x equals 3 to the power of 9. I see an equation here. That means the left side equal to the right side. Therefore, I have to find, if I have the right side 3 to the power of 9, I need to find what is missing here to have the same answer 3 exponent 5. That is 3 exponent 9. That means I can say that 3 exponent 4 times 3 exponent x has to equal to something like 3 exponent 4 plus x, because they have the same base, and I have the answer 3 to the power of 9. So if x it's unknown, with this way I can say that 4 plus 5 equal 9. That means my final answer x in this case, or the exponent, is 5. The next one, the same thing. I have an equation. That means the left side has to equal to the right side. So the right side, it's easy. It's negative 2 exponent 11. I'm lucky to have the same base, negative 2, negative 2, negative 2. That means in the left side, I have negative 2 as a base, and because it's multiplication, that means I'm going to add all the exponents together. 5 plus 4 plus x. It has to equal to negative 2 to the power of 11. That means the 5 plus 4 plus x has to equal to 11, which means 9 plus x has to equal 11. And you know it from the inverse method. I can reduce the 9 from each side to isolate x. So x plus 9, I will add the negative 9 in both directions to be able to isolate x. So the positive x cancel the negative x, the positive 9 cancel the negative 9. I will stay with x equal, in this case, it's going to be 2. So my answer is going to be 2. So, and this is true. I can verify negative 2 exponent 5 times negative 2 exponent 4 times negative 2 exponent 2. If I simplify as usually, I'm going to say this is the same base, negative 2, and I'm adding 5 plus 4 plus 2, which I will have negative 2 exponent 2, 11. And this is as a confirmation. I hope you understood this piece of multiplication of the power, and thank you for your attention.